So now it is time that we will look at the secant angle measurement and try to come up with a relationship between these two arcs that are intercepted and the angle measurement itself. I've taken the liberty already of kind of drawing in those arcs. We know the measure of this yellow arc would be the same as the measure of the central angle that intercepts that arc. The measure of this blue arc would be the measure of the central angle that intercepts the blue arc. So it's time to play around with it. Now, last time with the tangent angle, we looked at a difference of those two arc measurements. So let's do that again and see exactly what happens. So remember, we got to use our Greek letters here, and it looks like it's going to be this alpha minus this beta here, the alpha minus beta. So we'll just go ahead, go into our Greek alphabet and say alpha minus beta and see what happens. Oh, it's 59.8. Oh, okay, 59.8, but that's really, really close to this 29.9. Remember before we kind of tried our best to make it a whole number. So let's see, when this angle is 28, that difference is 56.1. Oh, okay, all right. 21.1 gives me 42.1. Looks to me like there's a little bit of error here. However, let's see what happens if we just go ahead and take this guy and divide it by 2, similar to how we did it with the tangent angle. And let me hit enter. We get 23.4 for this quotient and 23.4 for our angle measurement. We move it around a little bit. I'm at 28.3 on both. We make our circle a little bigger. We're at 37.4 for both. We move the center of the circle. We're at 36.4 once again for both. Notice how when this is changing, this quotient is staying the same as our angle measurement. Therefore, our conclusion for the secant angle measurement can be the same as our conclusion for the tangent angle measurement. Or in other words, a secant angle is equal to half the difference of the intercepted arcs. So the measure of a secant angle is equal to half the difference of the two intercepted arcs.